Now, we've been looking at probabilities involving the word "and" from a single stage experiment. So, like for instance, in this example right here, we're only selecting one person, so this is a single stage experiment. So, in this word "and," I'm just looking for people that satisfy both criteria simultaneously. Now we're going to look at "and" probabilities that come from a compound experiment or a multi-stage experiment. Right? So this is a slightly different usage of the word "and." Because this experiment is a compound experiment, you're going to have multiple stages involved. Now, if I'm trying to find the probability of A and B from a multi-stage experiment, that probability is going to be the probability of A times the probability of B. Now, this is going to be a little bit different because since I'm looking at multiple stages, what this word "and" is getting at is it's getting at that event A occurs and then B occurs. Okay, remember, there's more than one stage, there's more than one action. So what this is getting at is that event A will occur first, and then, as in the second stage of the experiment, B will occur. So the probability that A occurs and then B occurs will be found by multiplying the probabilities for the individual stages. So let's see this in action so we can kind of get an idea of what's going on here. So a bag contains 3 marbles, red, white, and blue. Now a marble is going to be randomly selected, returned to the bag, and a second marble is selected. So notice at this point in time there are 2 stages to the experiment. Right? There's 2 actions that have to happen before the experiment is over. What is the probability of drawing a red marble and then a blue marble? Now this one uses the words "and then." Sometimes you won't see the "then" word in the statement. So sometimes this question could just be worded, what is the probability of drawing a red and blue marble? The "then" is implied. Okay. Now if we're going to do one later on that talk about how do you not know whether or not the order is implied. But for this one, especially since it uses the word "then," that means you're going to draw a red marble first and then a blue marble second. Now one of the key things that's going to be on this problem is that the marble was returned to the bag. So on this next one it's going to be not returned. We're going to talk about how that impacts things. But on this one the marble is returned to the bag. Alright, so first stage. That'll be the first marble being drawn. So I'm going to kind of put a dot here to start my tree diagrams. Alright, so think about that first stage. You got these 3 marbles in a bag. You're going to pull a marble out. What could happen? Well, the marble you pull out could be red. The marble you pull out could be white, or the marble you pull out could be blue. So there are 3 possibilities, so I'm going to draw 3 branches. And at the end of the branches, I'm going to put what the outcome was, red, white, or blue. Alright, so you're going to observe what that marble is that you pulled out. You're going to record it somewhere. And then that marble is going to be put back in the bag. You're going to shake the bag up, and then you're going to pull out a second marble. What's the possibilities for that second marble being drawn? Well, it's kind of like the experiment reset itself, right? I mean, all 3 marbles are back in the bag. You're going to pull another marble out. So the marble that you pull out, it could be red, it could be white, it could be blue. And then that's going to be true regardless of what you pulled out on the first stage. So on the second stage then, from each one of these first stage, we're going to draw 3 branches and record what we could get. Okay, so then using that fundamental counting principle from the previous section, we can see here that in terms of the total number of outcomes, there are 3 outcomes on the first pull. There are then 3 outcomes possible on the second pull. So then overall there's going to be 9 outcomes in your sample space. Okay, so that will be the number of elements in your sample space. There are 9 of them, and then now we've actually accounted for, if you follow all these branches out, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes. So now we're going to answer the question, what is the probability of drawing a red marble and then a blue marble? Okay, so what this formula is getting at then is that it's going to be the probability of a red times the probability that the second one is blue. Alright, so the probability that the first marble was red. So on the first pull, there's one red marble out of 3 marbles in the bag. So the probability that that first marble is red is 1 out of 3. The marble is pulled out, it's observed, it's returned to the bag is shaken, and then a second marble is pulled out. So what's the probability that that second marble is blue? Well, there are 3 marbles in the bag, and there's one of them that's blue. So that'll be the probability on that second stage that a blue marble is pulled out. If you multiply these probabilities together, you get the probability that the first one's red and the second one is blue. It would be 1/9. Which, since we have the tree diagram right here, we can actually just see that from the tree diagram. So if we kind of just take a look at what's going on here, you have, in terms of your sample space, red, red, red then white, red then blue. This one would be white then red, white then white, white then blue. Right here, this would be blue then red, blue then white, blue and blue. So if I want to find the probability of red on the first pull and blue on the second pull, you can also argue, okay, well, there was 9 outcomes total in your sample space. How many of them satisfy being red on the first pull and blue on the second pull? Just this one guy. So it's the same probability we calculated here. This one is just drawing more upon using the tree diagram and visualizing it. And then this one is going to be more abstract using the formula approach. So now that we've looked at that scenario, let's explore how this next one is a little bit different. So this one, the bag still has red, white, and blue marbles, one of each. Marble is randomly selected, but is not returned to the bag, and then a second marble is selected. All right, so it's not returned. What's the probability of a red marble and then a blue marble? Now this one's going to be a little bit different, so to kind of visualize what's going on the first pull, you could get a red, a white, or a blue marble. Right? So you still have the 3 possibilities for the first pull, and this will still involve a 2-stage experiment. Right? You're still pulling 2 marbles out. Okay, so there are 3 possibilities for the first stage. Now the key thing here is once you pull a marble out, you're not going to put it back in the bag. It's going to remain out. So here's where things are going to change when we go to the second stage. So let's assume on the first stage you pull the red marble out. Okay, so imagine you've got this bag, you just pull the red marble out, and you're going to not return it to the bag. You're going to set it to the side. What marbles are left in the bag at that point? Just the white and blue marbles, right? So that'll be what ends up being on the branches off of red. So here's where things change a little bit because the marble is not going to be put back in the bag. What happens on that second stage is altered. So while there's 3 marbles in the bag on the first stage, there's always only going to be 2 marbles in the bag on the second stage. So on this one, there's going to be 6 outcomes total in your sample space. So let's see why it's going to be 6. So we've got these outcomes right here. So this would then be pulling a red and then a white marble and then a red and a blue marble. Now what if you pulled a white marble out first? What would be left in the bag? The red and then the blue marble, right? What if you pulled a blue marble out first? What would be left in the bag? A red marble and then the white marble. So then that ends up being our 6 outcomes. So this question is asking what's the probability of it being red and then blue. Now at this point in time you can reason through there are 6 outcomes total in your sample space. Red and blue is going to be this guy right here. So you can reason through it's going to be 1 out of the 6 possible outcomes. Otherwise, pulling it back to the formula, the probability of red times the probability of blue. Now for this formula, this probability right here is assuming that that first action already occurred. So what that means is on the first action, what's the probability that the marble is red? Okay, so on the first action, what's the probability that the marble is red? That would be 1/3. Now, that's assuming that this action has already happened. So it's kind of like we're sitting right here, this action has happened. Now, on the second stage, what's the probability that the marble is blue? So notice that there are only 2 marbles in the bag, and one of them is blue. So notice how the counts shifted right here because this is assuming that this action had already happened. So then multiplying through, you get your 1/6. Now that's also true on here. This action right here, this probability, it still assumes that this happened. Okay. So this probability is assuming that your red marble is already pulled out, that you're kind of sitting right here. But if you look at what's happening on the second branching, the probability that the second marble is blue would be there's 1 blue out of the 3 marbles in there. So this one, the experiment kind of reset itself, so we could kind of look at it like it was like a brand new trial. But on this one, we had to be a little bit careful because since we're sitting right here, it altered what was possible in that second step. Now these are assuming that things are happening in order, right? So this is red and then blue. So just to kind of change things up one more time, a bag contains 3 marbles, red, white, and blue. A marble is randomly selected, returned to the bag, and then a second marble is selected. What is the probability of drawing a red and a blue marble in any order? Now that's the sort of language that you would be looking to see to kind of appreciate. I'm not looking for the red to happen first and then the blue to happen second. I'm looking for it to be red and blue somehow at the end of the experiment. Okay, so this one, because you're pulling 2 marbles, this is going to be 2 stages. Since the marbles are being returned to the bag after the first pull, there are 3 possible marbles on the first pull, and there are 3 possible marbles on the second pull. So there is going to be 9 outcomes total in your sample space. On this one, it might be illustrative for us to re-sketch the tree so we could see what's going on. Okay, so you could have red, white, and blue on either of the pulls and either of the stages. Alright, so if I look at what's happening here, red and blue in any order. Well, there's a red and then a blue pull that happens right here, so I would want to count that. Here is I pulled a blue marble and then I pulled a red marble, so I would want to count that. So I would want to count either of those in any order out of the 9 possibilities in my sample space. So the probability of a red and a blue in any order, okay, out of the 9 possibilities in my sample space to satisfy it. Another way to maybe think about this problem is, granted it uses the word and, but because it's in any order, this is asking basically what's the probability you pull red and then blue, or you pull blue and red. So this is getting a little bit fancier here because notice it's in any order, so either one of these would be satisfied. Now notice that these are mutually exclusive, right? You can't have this happen and that happen simultaneously. It's kind of like you're running through the tree on this branch or you're running through the tree on these branches, right? There's no overlap. So the probability that you have red and then blue, red and then blue, okay, so there's a 1/3 chance the first one's red, there's a 1/3 chance the second one's blue. That gets you a probability of 1/9 that you're there. Now remember, for order probabilities, you would add up your probabilities on each of your different events. So the probability that the second one is blue and then red. Blue is, there's a 1/3 chance that the first one is blue. There is a 1/3 chance that the second one is red. Multiplying those together gets you another probability of 1/9. And then you would add up your different probabilities for your different events, and you still get your 2/9. So this is obviously a much more complicated scenario because it's in any order. You would have multiple outcomes in your experiment that could satisfy it. But you're looking for this verbiage to know that you would want to pull multiple outcomes as opposed to having it very specifically an action on the first step and then that action on the second step. Now we had to pay particular attention on these ones, on these multiple examples, about whether or not the marble was returned to the bag or not. So like on these first two, this one was returned to the bag, this one it was not, and that severely affected how I continued the tree moving forward, right? The difference between these two examples is a pretty important idea, and it talks about independence. Events are going to be considered to be independent when the outcome of one event has no effect on the outcome of a second event. So then dependent events are going to be events that are not independent. In other words, the occurrence of one event affected the occurrence of the other. Okay, so the occurrence of, for instance, on this example right here, this is going to be, so when the marble was returned to the bag, this is going to be a scenario where this is independent. Independent. You can kind of think about the experiment like resetting itself. So on the second pull, it didn't matter what happened on the first pull, right? On the second pull, all three marbles are back in the bag and the experiment reset itself. It has no memory. It doesn't care what happened on the first pull, whatever. On this one, because the marbles were not returned to the bag, this is dependent. It really matters what happened on that first stage for us to consider what was possible on the second stage. So the branches right here, we had to be very careful about who we listed because it depended on what happened on the first stage and who we were kind of coming off of. So when the events are dependent, that's what's going to start impacting those probabilities on those successive stages. So we're going to be looking at some multiple examples coming forward about independent versus dependent because it's going to affect then what sorts of probabilities that we're using.